In the vast silence of the universe's beginning, there was only the whisper of the cosmic microwave background radiation and the moments when the first stars forged heavy elements through nucleosynthesis. Billions of years later, on a planet formed from these elements, emerged humankind, a product of complex biochemical processes. With eyes yearning to understand the cosmos, a mind relentlessly questioning whys and hows, and hands capable of fundamentally altering its surroundings. Science became the most refined expression of this infinite curiosity, the brightest projector reaching into the unknown. But is the hand holding this projector obligated merely to observe the illuminated area, or must it also bear the responsibilities brought by the light and shadow it creates? Does science, this most potent tool of humanity's collective intellect, carry an inherent moral responsibility? The answer to this profound question is a constantly resonating theme, seeping from the controlled environments of sterile laboratories into the intricate and unpredictable fabric of life. The lighthouse at the edge of knowledge, illumination, and responsibility. Let us imagine science as a colossal lighthouse standing on the edge of an immense ocean of unknowing, illuminating shores shrouded in mist. Its fundamental function is to scan the dark waters, make the unseen visible, and chart safe courses for the ship of humanity. As the lighthouse's lumen output increases, that is, as the body of scientific knowledge grows, the horizon is pushed further back. However, this increased illumination reveals not only safe harbors but also treacherous currents, unexpected shallows, and the wreckage of fragmented ships. Knowledge itself, such as the equation E=mc² or the double helix structure of DNA, does not inherently carry value judgment. The potential of a uranium atom or the function of a gene bears no moral quality. But the will that controls the lighthouse's mechanism, the human factor that directs the beam of light determining the direction and priorities of scientific research, can never be entirely neutral. It is in these moments of choice, when decisions are made about which shores to illuminate and which questions are deemed worthy of asking, that science ceases to be a pure instrument of observation and acquires a moral dimension. Is the scientist, positioned as the guardian of the lighthouse, merely a technician tasked with maintaining the optical system and replenishing its fuel? Or are they a possessor of conscience, weighing not only the potential of their powerful light to guide, but also the risk of misdirection or revealing dangers during stormy nights? The synthesis of a new chemical compound could hold the cure for a deadly disease or form the basis of a weapon of mass destruction. The development of genome editing techniques offers hope for treating hereditary blindness while simultaneously opening the door to designs with unforeseeable ecological or societal consequences. The discovery of knowledge often unleashes a series of potentials whose full outcomes cannot be precisely predicted. Therefore, the lighthouse must illuminate not only the distance but also its own base, the potential consequences of its actions. This requires more than epistemic responsibility. It demands ethical foresight and prudence. In this context, it is insufficient for science to limit itself solely to the factual planes of what and how questions. Normative questions such as why are we conducting this research, for whose benefit, and at the cost of which potential risks, must occupy a central place in every research area illuminated by the lighthouse. The very act of illumination, the process of generating knowledge, inevitably weaves a web of responsibility. For knowledge is transformative power, and all power carries the potential for misuse. This potential necessitates management through balance, diligence, transparency, and a robust ethical framework. The lighthouse of science must constantly subject not only the external world but also its own internal workings and societal interactions to the light of moral scrutiny. The legacy of Prometheus, stealing fire, and the aftermath. In ancient Greek narratives, the Titan Prometheus steals fire, a divine monopoly, from Olympus and gifts it to mortal humans. This rebellious and audacious act grants humanity the means to banish darkness, warm themselves, work metals, and build complex societies. It ignites the fuse of civilization. However, this priceless gift brings with it both a terrible punishment for Prometheus and, for humanity, the destructive potential of fire. Science can be seen as the Prometheus of the modern age. It unveils the secrets hidden in nature's depths, from the behavior of fundamental particles to the formation of galaxies, from the chemical basis of life to the neural correlates of consciousness. Through technology, it offers these discoveries for humanity's service. The control of nuclear fission, the manipulation of the genetic code, the rise of artificial intelligence, these are the new, far more potent fires of our time. But the true lesson of the Prometheus myth lies less in the gift itself and more in its uncontrollable consequences. The fire stolen from Olympus can be not only a life-giving hearth but also an uncontrolled conflagration, an instrument of war. Similarly, every revolutionary capability offered by science carries a profound dilemma. The immense energy within the atomic nucleus can illuminate millions of homes. Yet, as witnessed in Hiroshima and Nagasaki, it can also obliterate cities and hundreds of thousands of lives in seconds. Genetic engineering promises to cure single-gene disorders like sickle cell anemia, while also presenting ethical quandaries such as making irreversible changes to the human gene pool or creating enhancements that could deepen societal inequalities. Artificial intelligence revolutionizes fields from disease diagnosis to logistics optimization, while simultaneously raising alarming possibilities like autonomous weapon systems, mass surveillance, or radical shifts in the labor market. The legacy of Prometheus painfully reminds us that science cannot content itself merely with the acts of discovery and understanding. It also bears an active responsibility to confront the consequences of the knowledge and power it generates, to attempt to foresee these outcomes, and to minimize potential harm. Just as Prometheus, who gave fire, could not dictate its use, science cannot guarantee that the knowledge and technology it produces will be used solely for beneficial purposes. However, it has the obligation to initiate and sustain an open and honest dialogue about the nature of this power, its potential impacts, and its ethical boundaries. To evade this responsibility harms both the intellectual integrity of science itself and the future of the humanity it is expected to serve. Beyond laboratory walls, the window opening onto society. In past centuries, science might have been perceived as a more isolated endeavor, an abstract pursuit conducted in the ivory towers of universities or private institutes, whose results were understood only by experts, detached from the daily life of society. However, in the process that began with the Industrial Revolution and accelerated particularly from the latter half of the 20th century, these metaphorical walls have largely crumbled. Today, science and its product, technology, are so deeply interwoven into the fabric of modern life that scarcely any domain remains independent of them. Everything from the semiconductor technology in the smartphones we use for communication, to the genetic makeup or agricultural techniques of the food on our tables, to the medical imaging devices and pharmaceuticals used in diagnosis and treatment, to our energy production methods and even our forms of artistic creation, is a direct or indirect result of basic or applied scientific research. Laboratories are no longer inward-looking fortresses but wide windows constantly opening onto society with their findings and impacts. Through these windows flows not only new information, theories, technologies, and products outward, but also society's values, ethical norms, social concerns, political priorities, and economic expectations seep inward, influencing the research process itself. Decisions about which research areas will be generously funded by public or private sectors, which scientific questions will be deemed urgent or important, how the obtained results will be interpreted and shared with the public, are no longer made solely on the basis of scientific merit, but are also under the influence of complex social, economic, and political factors. For example, the allocation of more resources to drug research for a common lifestyle disease rather than a rare one is related not only to scientific potential but also to market size and profit expectations. The process of developing a vaccine during a pandemic depends not just on the success of virology, immunology, and clinical trials, but also on countless social and ethical factors like production capacity, distribution logistics, patent rights, international cooperation, and public trust in vaccination. Consequently, the responsibility of scientists cannot be confined merely to solving technical problems within their narrow fields of expertise. They must also consider the broader societal context of their work, its potential benefits and harms, its ethical dilemmas, and its dimensions of justice. When developing an algorithm, they must question not only its mathematical efficiency but also whether it might reinforce existing societal biases. When proposing a new energy technology, they must evaluate not only its technical feasibility but also its environmental sustainability, economic accessibility, and social acceptance. Looking through the laboratory window requires seeing not just the cell culture in the petri dish or the distant galaxy in the telescope, but also the complexity of life flowing past that window and the potential impact of one's own work on that life. This is an integral part of science's contemporary moral responsibility. The atom's whisper, conscience's cry. Towards the middle of the 20th century, a group of brilliant physicists discovered the theoretical and practical means to unlock one of matter's most fundamental secrets: the immense energy hidden within the atomic nucleus. This was a stunning confirmation of the mass-energy equivalence predicted by Albert Einstein's E=mc², an intellectually dizzying achievement that forever changed our understanding of the universe's fundamental forces. However, the whisper of this scientific triumph soon transformed into the deafening cry of the atomic bombs detonated over Hiroshima and Nagasaki in the final days of World War II. These events, in which hundreds of thousands perished instantly or in the aftermath, became the most tragic and concrete proof that scientific knowledge could be converted into unprecedented destructive power. A journey begun with pure intellectual curiosity had chillingly revealed humanity's capacity for self-annihilation. Many scientists involved in efforts like the Manhattan Project, which developed the atomic bomb, underwent a profound moral upheaval and conscientious questioning upon confronting the horrific outcome of their work. The sentiment expressed by the project's scientific director, J. Robert Oppenheimer, after the first successful atomic bomb test, quoting the Hindu scripture Bhagavad Gita and seeing himself as death, the destroyer of worlds, is one of the most famous articulations of this inner conflict and the heavy burden carried by scientific discovery. Some scientists, like Leo Szilard, were aware of the dangers of this power from the outset and engaged in political efforts to prevent or control its use. This dramatic experience taught a bitter lesson: that science cannot be, as often claimed, a value-free, neutral pursuit, and that the consequences of scientific activity can have profound ethical and human implications. The splitting of the atom was not just a revolution in nuclear physics but also a turning point for science ethics and the social responsibility of the scientist. This event indisputably established the responsibility of scientists not only to discover but also to attempt to foresee the potential good and bad applications of their discoveries, to inform the public and policymakers about these risks, and to actively strive to prevent the misuse of knowledge for humanity's detriment. The cry of conscience born from the atom's first whisper is a powerful and enduring warning, constantly reminding us that even in the most abstract theoretical work in laboratories, the moral weight of potential consequences must never be ignored. The existence of organizations like the Bulletin of the Atomic Scientists and symbols like the Doomsday Clock are institutional and public reflections of this consciousness of responsibility. The genetic code, the labyrinth of morality. The race to unravel the secrets of DNA, the molecular basis of life, gained momentum in the latter half of the 20th century, culminating in the completion of the Human Genome Project in 2003. Mapping this complex code, composed of billions of base pairs, opened an unprecedented door to understanding the molecular mechanisms of genetic diseases and identifying potential therapeutic targets. In the ensuing years, the development of revolutionary gene editing technologies, particularly CRISPR-Cas9, granted scientists the power to intervene in the code of life with previously unimaginable precision. While these technologies offer immense therapeutic potential for correcting many hereditary disorders like cystic fibrosis and Huntington's disease, or combating viral infections like HIV, they have simultaneously placed us squarely in the middle of a complex and winding labyrinth of morality. The ability to read, interpret, and now alter the genetic code raises profound ethical, social, and philosophical questions that fundamentally challenge humanity's relationship with its own biological nature. Which genetic flaws are medically necessary and morally acceptable to correct? Where should the line be drawn between treating disease and genetically enhancing human capabilities? Is it ethical to attempt to genetically manipulate traits like intelligence, athletic ability, or physical appearance, And what societal consequences might such practices entail? Who will have access to these powerful technologies? And will this further deepen existing social and economic inequalities? Most critically, what are the long-term biological and ethical consequences of making irreversible changes to the human germline sperm, eggs, or embryos which will be passed down to future generations, thereby altering the genetic heritage of the human species? These are not merely questions for molecular biologists or geneticists, but fundamental existential questions that require the participation of ethicists, lawyers, sociologists, policymakers, and society as a whole to answer. As we decode the code of life, we need new ethical principles, robust regulatory frameworks, and continuous societal deliberation to avoid losing our way in the labyrinth of morality. As science illuminates the complex paths of this labyrinth, it must also bear the responsibility of indicating which trails are safe and which might lead to dangerous precipices or unexpected pitfalls. In the genetic age, the task of science is not only to show what is technically possible but also to help determine what is morally prudent, just, and right for the long-term well-being of humanity. As we navigate this labyrinth, we must develop ethical reflection and societal wisdom that can keep pace with the speed of scientific progress. The illusion of pure science, the shadow of every discovery. A common argument sometimes voiced within the scientific community and philosophy is that basic science, or pure science as it is often called, is inherently value-free and morally neutral. According to this view, the primary aim of science is solely to produce knowledge for understanding the universe and its workings, without any specific practical application in mind. How this knowledge is later used or interpreted is the responsibility not of scientists, but of engineers, politicians, businesses, or society at large. This perspective tends to absolve the scientist from the moral burden of the potential negative consequences of their research, framing their work as a pure pursuit of intellectual curiosity. However, this distinction is an illusion, difficult to sustain both practically and philosophically, and potentially even dangerous. The process of knowledge production never occurs in a sterile vacuum, completely isolated from the social context, cultural values, and the researcher's own implicit assumptions. Every step of the process which scientific questions are deemed worthy of investigation, which hypotheses are formulated, which research projects receive public or private funding, which experimental designs are chosen, how the resulting data are interpreted, and which findings are published in prestigious journals while others are ignored actually reflects specific value judgments, societal priorities, economic interests, and sometimes conscious or unconscious biases. For example, the historical focus of medical research predominantly on male subjects, failing to adequately consider the physiological differences of women, led to significant knowledge gaps and treatment inequalities in women's health. This is a concrete example of how even a seemingly pure quest for knowledge can be influenced by a value-laden context like gender inequality and systematically exclude certain groups. Similarly, biases present in the data used to train artificial intelligence algorithms can lead the algorithms themselves to produce discriminatory outcomes. Furthermore, nearly all fundamental scientific discoveries have the potential, sooner or later, in predictable or unpredictable ways, to lead to practical applications. Every discovery casts a kind of technological or societal shadow. The understanding of the basic physical principles of the laser, initially pure quantum mechanics research, has revolutionized countless fields over the years, from medicine and communication to industry and military applications. A new molecule synthesized by an organic chemist could be the precursor to both a life-saving antibiotic and an environmentally harmful pesticide. Therefore, the theoretical distinction between pure science and applied science often blurs in practice, and even a scientist conducting basic research cannot completely ignore the potential good or bad uses the shadow of their discovery. The innocence of knowledge begins to be questioned the moment it leaves the controlled environment of the laboratory and enters the complex interactions of the real world. And these potential impacts necessitate ethical consideration from the very outset of the research. Curiosity's compass, ethics guide. One of the most defining characteristics that distinguishes the human species, perhaps its most fundamental driving force, is the unceasing sense of curiosity about the universe it inhabits and its own nature. This irresistible intellectual attraction towards the unknown blossoms with a childlike why, and, nurtured by the systematic inquiry of the scientific method, transforms into a vast quest for knowledge extending from the bizarre world of subatomic particles to the farthest corners of the cosmos, from the origins of life to the mysteries of consciousness. Curiosity is the compass in the scientist's soul. It constantly points towards new horizons of discovery, presents new riddles awaiting solutions, and inspires the pushing of knowledge's boundaries. However, a compass merely indicates the direction to travel. It does not specify how the journey should be undertaken, which paths are safe, which terrains are perilous, or how one should behave towards others encountered along the way. It is precisely at this juncture that the moral dimension of science, namely ethics, comes into play. Ethics is the indispensable guide for science's journey. It tempers curiosity's boundless and sometimes reckless desire for exploration, delineates the boundaries of research activities, and questions the rightness and legitimacy of the steps to be taken. Protocols aimed at preventing unnecessary suffering in animal research, respect for the autonomy of human subjects and obtaining their informed consent, the ethical use of placebo controls in clinical trials, the honest and transparent reporting of research data, the declaration of conflicts of interest, and the rigorous assessment of potential environmental or societal risks. These are the concrete and institutionalized manifestations of ethics in scientific practice. Ethical principles and the committees that oversee them, such as institutional review boards at universities or guidelines like the Declaration of Helsinki, attempt to ensure that the scientific journey remains within both safe and morally acceptable limits. A journey undertaken without a guide, recklessly advancing only in the direction indicated by the compass, however exciting, carries the potential to harm both the traveler and their surroundings. Therefore, science cannot content itself with blindly chasing after curiosity alone. It must also constantly weigh the moral consequences of this pursuit, its potential impacts and alternative paths. Sometimes, strong ethical concerns may necessitate halting a particular research project, modifying its methods, or postponing the search for the answer to a question that sparks curiosity. This should not be viewed as a constraint or an obstacle to science, but rather as a safeguard mechanism that preserves its long-term credibility, societal acceptance, and ultimately, its potential to serve humanity's benefit. When the compass of curiosity and the guide of ethics work in harmony rather than conflict, science can both advance towards its goal of understanding the universe and do so in a responsible, just, and humane manner. Seeds sown for the future, today's science, tomorrow's world. Scientific activities not only help us understand the present moment and devise solutions to current problems, but also inevitably shape the future. Every theoretical step taken in a research laboratory today, every new material developed, every ecological model constructed, or every genetic mechanism discovered is, in essence, a seed sown for the world of tomorrow. How these seeds will sprout, what kind of fruits they will bear, sweet or poisonous, or what unexpected thorns they might grow depends largely on our scientific choices today, our ethical evaluations, and how we choose to use this knowledge. Complex computer models predicting the future impacts of climate change, the increasing integration of artificial intelligence into decision-making processes, research into next-generation energy technologies as alternatives to fossil fuels, or efforts to design new life forms through synthetic biology. All these directly or indirectly construct tomorrow's society, economy, environment, and even humanity's own nature. Because of these foreseeable and unforeseeable future impacts, the moral responsibility of science entails an obligation not only towards current living beings and societies but also towards future generations yet unborn. Attempting to foresee the long-term environmental impacts, e.g., biodiversity loss, persistent pollution, climate instability, social consequences, e.g., unemployment, inequality, cultural change, and ethical implications, e.g., erosion of privacy, redefinition of humanity of the scientific work we conduct and the technologies we develop today, and incorporating these foresight exercises into our decision-making processes is a fundamental part of this intergenerational responsibility. For example, A scientist developing a new agricultural technology must comprehensively evaluate not only the yield increase but also the long-term health of the soil, the impact on water resources, the socio-economic consequences for smallholder farmers, and potential threats to genetic diversity. Similarly, an urban planner must consider not only today's traffic flow but also future climate change adaptation, energy efficiency, and social inclusion. When sowing seeds for the future, we must understand not only the genetic potential of the seed but also the quality of the soil into which it will be sown, i.e., the social structure, the prevailing climatic conditions, i.e., global trends, and all possible interactions. While science provides the necessary knowledge to understand this complex system, it must also serve as a moral compass in evaluating which types of seeds are most likely to create a sustainable, just, and desirable future for humanity and the planet. In short, today's science is not merely an observer but an active architect of tomorrow's world, and ensuring that this architecture is built on solid, livable, and ethical foundations is the shared moral duty of the scientific community and all of society. The scientist, explorer, or guardian. What is the fundamental role of the scientist? Should we see them as a courageous explorer venturing into dangerous waters to map the unknown, discovering new lands? Or as a protective guardian, concerned with the ecology of these discovered lands, the rights of their inhabitants, and their long-term well-being? In fact, these two roles need not be mutually exclusive opposites. Rather, in an ideal scientific practice, they should be seen as two fundamental archetypes that complement and balance each other. Without the passion for discovery, the explorer's spirit, science stagnates. New horizons cannot be opened, progress cannot be made. But without the consciousness of guardianship, a sense of responsibility for the potential consequences of discoveries, this progress can become uncontrolled, potentially destructive, and ethically problematic. The explorer aspect drives the scientist to constantly ask new questions, push the boundaries of existing paradigms, critically examine established dogmas, and propose radical new hypotheses. This is the fundamental engine that fuels the dynamism, creativity, and, most importantly, the capacity of science to understand the universe. The great revolutions in the history of science, Copernicus's heliocentric system, Darwin's theory of evolution, Einstein's theories of relativity, are all products of this explorer spirit. However, the guardian aspect endows the scientist with the ability to pause and reflect, to evaluate the potential impacts of the knowledge and power gained, to weigh risks, and to assume responsibility. In this capacity, the scientist warns society against potential misuses of their discoveries, seeks ways to share their knowledge not only with academic circles but also with the public, constantly questions the ethical boundaries of their research, and considers the impacts on future generations. Just as a mountaineer aims both to climb a challenging peak and to descend safely while respecting the mountain's fragile ecosystem, the scientist must balance these two impulses. The ideal profile of a scientist is one who successfully integrates these two roles within their personality and professional practice. They are both a passionate explorer delving into the deepest secrets of the universe with their mind, and a responsible guardian looking out for the well-being of humanity and the planet it inhabits with their conscience and ethical sensitivity. This delicate balance ensures that science both continuously progresses and maintains its moral compass, maximizing its potential to serve humanity. Thus, the scientist is not merely an objective observer pursuing truth, but also an active world citizen aware of the societal consequences of the power and knowledge that truth reveals, and feeling the responsibility that comes with it. The price of silence, echoes of unspoken science. Science speaks not only through the papers it publishes, the theories it presents, or the technologies it develops, but sometimes also through its profound and meaningful silence, or it is judged for remaining silent when it should have spoken. When scientists or institutions choose to remain silent in the face of unethical practices within their fields, potential dangers, or the deliberate distortion of information, it is not a neutral stance but rather a moral position with potentially severe consequences. History is replete with examples of preventable tragedies that occurred because the dangers of scientific knowledge were not voiced loudly or timely enough, or because the voices that were raised were suppressed. The tobacco industry misleading the public for decades despite its own research indicating cancer risks. The continued use of asbestos long after its dangers were known. The ignoring of early warning signs for certain environmental disasters, or the academic legitimacy once afforded to discriminatory ideologies lacking scientific basis, like eugenics. These are all bitter echoes of this dangerous silence or delayed speech. Therefore, the moral responsibility of science is not limited to producing accurate and reliable knowledge. It also includes speaking out on important issues related to this knowledge, informing society, and warning when necessary. Scientists have a crucial societal role and responsibility to inform the public clearly and understandably about the potential risks and benefits of developments in their fields of expertise, to provide evidence-based advice to policymakers in their decision-making processes, to actively combat misinformation and disinformation, especially regarding health and the environment, and to speak out against unethical practices they witness among their colleagues or institutions. Scientific knowledge should not remain confined to the pages of peer-reviewed journals or conference halls. It must meaningfully contribute to society's collective intelligence, public discourse, and democratic decision-making processes. The price of silence is not just the occurrence of preventable harm or missed opportunities. It is also, and perhaps more importantly, the fundamental erosion of public trust in science and scientists. Science is, by its nature, a process open to doubt, questioning, and continuous self-correction. However, it maintains its strength and legitimacy only when this process is transparent, accountable, and intertwined with societal dialogue. A scientific culture that speaks, questions, presents evidence honestly, acknowledges uncertainties, openly discusses potential risks, and warns when necessary not only ensures healthier scientific progress but also provides an indispensable foundation for building a more informed, resilient, and just society. The conscience of science can only truly fulfill its function through a brave and honest voice that resonates beyond laboratory walls into the public sphere. There is no doubt that science, this immense power born from humanity's desire to reach for the stars, bears a heavy, inescapable, and constantly redefined moral responsibility upon its shoulders. This responsibility stems not from the discovered neutron or gene itself, but from the intentions, actions, and omissions of the human beings who seek, find, interpret, share, and ultimately use that knowledge. Science is the sharpest intellectual tool humanity possesses for solving the problems it faces and understanding the universe. Yet, like any powerful tool, it can both open doors to unprecedented good and serve unimaginable evil. To consistently keep this power in the service of goodness, justice, and sustainability is the shared and ongoing moral duty not only of scientists in the narrow sense, but of educators, policymakers, civil society, and every conscious individual that is, of all humanity. On our journey from our cosmic origins in stardust to our complex present-day civilization, as we fuel the fire of our curiosity, we must never extinguish the light of our moral awareness, but carefully take our steps in this dual illumination.